Hello, and welcome back to episode 12 of Crash Course Trigonometry, where I try to give you a basic understanding of trigonometry wherever you need it in life. Today we're going over translations of graphs. So we're going to start off with domain and range. So what is domain and range? Domain is x and range is y, put in simple terms. So domain is whatever x's can be put into a function, and range is whatever y's are able to come out of the function. So let's use some examples. We have a parabola and the tangent graph here. Now this parabola, you can put any x into it and get a y out of it in the function. This is x squared. You can put any x in and get a y out. You can get an answer. But you can't get any y out, because if you square something with the parabola, you can't get a negative number. So all of the domain of this parabola right here would be all real numbers, all x's, anything. But the range would be all real numbers greater than 0, because you can't square something and get a negative number. With the tangent graph, we can see that you can get any number. It goes forever in both directions. You can get any y, but you can't put any x into the tangent graph, and that's because there are asymptotes that exist. And asymptotes are undefined points on the tangent graph. So say you wanted to put a pi halves into tangent, then you just can't, because tangent is sine over cosine, and that'd be 1 divided by 0, which doesn't exist. So the domain of tangent would be all real numbers except for 0, pi halves, 3 pi halves, 5 pi halves, 7 pi halves, any pi halves. So technically be pi halves plus 2 pi. K, which could be anything. But you can get any y out. So the range would be all real numbers, because no matter what you put in, you can get any number. It just depends what you put in. Moving on to translations, we have this equation right here that tells you how all the translations of graphs work. We have y equals a sine of bx plus c plus d. And I know that sounds like a lot, but if you think about it, it's just another formula to get you where you need to be. So a gives you the amplitude of a graph, b helps you get the period of a graph, c helps you get the phase shift of a graph, which is horizontal shift, and d helps you get the vertical shift of a graph. So these translations help us to know how a graph moves and how it differs from the parent graph, So let's move into those. Going down the line, we can start with amplitude, which is marked by the letter A in that formula that I just showed you. Amplitude is how high or low a graph dips or peaks. So with a normal cosine graph right here, we have y equals cosine x. The amplitude is 1 because there's a 1 in front of that cosine. It's invisible because that's what math does. But the cosine graph goes up 1 and down 1, and up 1 and down 1, and up 1 and down 1. So the amplitude would be 1. Here's some other examples. In the dotted line, we have a normal cosine graph with amplitude 1, but this purple one, this indigo one right here, has amplitude 2 because it goes up 2 and down 2, and up 2 and down 2, and up 2. But this darker purple right here has an amplitude of 1/2 because it goes up 1/2, down 1/2, up 1/2, down 1/2. So in short, amplitude tells you how high a graph goes and how low it goes. So how do we mark these in our equation? Well, the graph with amplitude 1 is just cosine of x, and the graph with amplitude 2 is y equals 2 cosine x, because that 2 makes the graph much bigger and lower. And then the amplitude of 1/2, which is the dark purple, would be y equals 1/2 cosine x. There's a formula to find amplitude as well, and it's 1/2 max minus min. The maximum of a graph is the highest point of the graph, and the minimum of a graph is the lowest point of the graph. So say we have the highest point right here, which is 2, and the lowest point right here, which is -2 for this stretched out graph. Then we have 2 minus -2, which is 4, and half of 4 is 2. So we find that the amplitude is 2, and it works with the equation. A negative amplitude also flips the entire graph horizontally. So imagine these, and then you just flip them over like a normal piece of paper. So here we have y equals negative cosine x. It's the exact same as the normal cosine x graph, but it is flipped over. So instead of starting at 1, it starts at -1. And it's the exact same graph, it's just upside down. Moving on to part B, we have period, which is marked as B in the formula from our first slide. The period of a graph is the amount of time it takes for that graph to start repeating itself. In circular functions, graphs repeat forever, like this sine graph. It'll go up and down until the end of time. But if we just look at one section of it, we can find, we look at one period of the sine graph, and that is the one piece that will repeat. So if we have this normal sine graph, right? One period of a sine graph would be 2 pi, because it goes from here to here, and it just repeats till it hits 2 pi. That's where it repeats. So here we have one period of a sine graph. It goes from 0 to 2 pi, and then after it hits 2 pi, it just repeats the exact same function and the same values. So period, you can find the equation to find the period of a function is 2 pi over b, because 2 pi is the normal period of the function, which is, in this case, sine, over b, which is what is given in the equation. So down here I have a couple examples. The green example, the period is only pi. It's not 2 pi, it's just pi. So the sine graph is kind of squished, you know? And then in the middle, we have a dotted line, which is just the normal sine graph, period 2 pi. And then we have one more graph, which is a dark purple line, and it's period of 4 pi. So it's kind of stretched out, and it repeats every 4 pi units. Now, how do we find these equations? The squished little pi period would have y equals sine of 2x. That's as an equation, because the period is 2 pi over b, right? And if the b would be 2, the period would be 2 pi over 2, which would equal just pi, which is our period. The normal period, 2 pi, is just y of sine x, and period 4 pi would be y equals sine of 1/2 x, because 2 divided by 1/2 would give us 4. And then our period would be 4 pi. So that's the basics of periods of a graph. It's just the section that repeats over and over is one period. And let's move on to phase shifts. Next, we're going to move on to part C and D of our translations, which is phase shift and vertical shift. Phase shift is horizontal movement of a graph, and vertical shift is vertical movement of a graph. So if a graph moves up or down. So we're looking at this, and I put a lot on one slide, but we can see that if C is negative, the graph moves to the right, and if C is positive in that first equation, then the graph moves to the left, which is kind of counterintuitive. It does the opposite of what you'd think it would do, but it's just, one of those things in math that you have to remember. So here we have an example of phase shift, and we have y equals sine of x minus pi halves. So in red, in this dotted line, we have the normal sine graph, has a period of 2 pi, it starts at 0, and it goes up and down and up. And then if we use sine equals x minus pi halves, this graph actually moves to the right pi halves units, because c is negative, so it moves to the right pi halves units. So we have the same sine graph, it's just shifted over. At pi halves, sine used to be 1, but now it's pi, and at 3 pi halves, it used to be -1, but now it's 0, and it's just shifted over, and that's really it. And people get so scared of phase shift, but really it's not that bad. You just look at it and you're just like, oh, the graph moves to the right, pi halves units. Oh, the graph moves to the left, 3 units, That's the basics of phase shift. Next we have vertical shift, which is if a graph moves up or down. Here we have a normal sine graph again in dotted lines, and if we look at y equals sine of x plus 2, it's just that same y equals sine of x graph, but it is shifted up 2 units. It's the exact same, just everything is up 2 more units. The y equals 0 is now y equals 2, y equals 1 is now y equals 3, and positive d for vertical shift moves the whole graph up, and a -1 moves the whole graph down. Those actually follow, what you would use intuitively. Positive goes up and negative goes down. But yeah, those are the basics of phase shift, and that's the end of our translation section on trigonometry. I hope this helped you out a little bit, and I hope you have a wonderful day. Bye!